Light is much more than just a beam moving through space. It's a universal traveler, a restless pulse of pure energy that interacts with atoms, curves around obstacles, and reflects off surfaces, painting the world with color and clarity. Every sunset, every starry sky, and every loved one's face that we see is a gift carried by light. And yet behind this ordinary miracle lies a quiet rule. The speed of light never changes. It moves at the same pace, unwavering and constant, a silent code etched into the foundation of reality. Tonight, let's continue our journey through this cosmic mystery. Imagine light not as a physical object, but as a ceaseless wave, an invisible thread that stitches together everything we know. It never rests, never stops, never slows down. It dances across galaxies and bounces off the moon, traveling for billions of years just to meet your eyes in a single blink. Think about what that means. Every time we look into the night sky, we are not just looking into distance, we are looking into time. Light from stars doesn't arrive instantly. That gentle shimmer in the sky may have started its journey thousands or even millions of years ago. When you gaze at a distant galaxy through a telescope, you're peering into its ancient past. In this way, light is the universe's storyteller, delivering messages from across time and space. But how did humanity come to realize that light had a fixed speed at all? Let's gently float back in time. Long before satellites orbited Earth and lasers zipped through labs, our ancestors lived under the glow of fire and stars. In a world without electricity, where the night was truly dark, early thinkers wondered what light was, how it moved, and whether it moved instantly. The first serious attempt to measure the speed of light came from an unlikely place, the moons of Jupiter. In 1676, a Danish astronomer named Ole Romer noticed something peculiar. As he watched Jupiter's moon Io disappear behind the planet, he realized that its timing seemed to change depending on Earth's position in orbit. When Earth was moving away from Jupiter, Io appeared later. When Earth was closer, Io appeared earlier. From this, Romer proposed something radical. Light doesn't travel instantly. It takes time. His measurements weren't perfect, but they opened a door that would never close again. For the first time, humans grasped that light had a speed, and that speed was measurable. Over the centuries, others refined these calculations, using lanterns, mirrors, and eventually lasers. But no matter how clever the experiment, one thing became increasingly clear. The speed of light was not only constant, it was unbreakable. Fast forward to the modern era. We now understand that light travels at its specific speed because it moves through the fabric of space-time itself. And this fabric isn't like a road or a tunnel. It's more like a set of invisible rules that shape everything, including time, distance, and motion. To change the speed of light, you'd have to rewrite the rules of reality. That's why no matter how powerful our machines, no matter how massive the explosions, we can't push anything, not even a single particle, past that ultimate limit. Still, this speed limit doesn't make light boring or predictable. On the contrary, it's precisely what gives light its mystical power. It is fast enough to seem instant, yet slow enough to be measured and studied. And in the space between those two truths lies a universe of meaning. For instance, think about how light behaves when it enters a new material, like air to water. It bends. This is called refraction. You've seen it when a straw appears broken in a glass of water, or when sunlight splits into a rainbow through a prism. What's happening here is that light slows down in denser materials. Not permanently, but just while it's inside them. But here's the twist. Even though light slows down in glass or water, once it exits, it instantly returns to its universal speed, as if the universe hit resume on the cosmic speed dial. No matter how many times light is bent, bounced, absorbed, or reflected, it never forgets its pace. And light doesn't just show us beautiful things, it helps us measure reality itself. With light, we can calculate the distance to stars. We can analyze distant planets to look for signs of life. We can observe black holes by watching how light bends around them. Even time itself, as measured in your GPS or your wristwatch, depends on the behavior of light. Here's something to think about. If light didn't have a consistent speed, everything would fall apart. Physics would crumble. Communications would collapse. You wouldn't be able to make sense of movement or distance. Reality would become a blur without context. That's why physicists see light not just as a tool or a wave, but as a constant, a reference point against which everything else is measured. In fact, the meter, the standard unit of length, is defined based on how far light travels in a vacuum in 199,792,458 seconds. So, when we say the speed of light is 299,792 kilometers per second, we're not just quoting a number. We're quoting the most trusted constant in the entire universe. And there's something strangely comforting about that. In a world of change, chaos, and uncertainty, light moves forward, always. Never faster, never slower, like a heartbeat that pulses behind the scenes of everything. As we wrap up this segment, remember, the next time you flick on a lamp, look at the stars, or see a rainbow. You're witnessing a performance billions of years in the making. You're watching the universe communicate, in silence, in color, in light. In the next segment of Infinity Beyond, we'll explore how gravity bends light, how black holes trap it, and what Einstein's equations reveal about the deepest structures of space-time. Until then, let your curiosity glow, and keep traveling with us, gently beyond.